Good afternoon. What's up? Okay. I think microphone was being really weird earlier today. It wasn't working, but I think I have it fixed for now. I'll keep an eye on it to make sure it doesn't go out. But all right, happy Friday. Made it through week 5. And today we're not going to do anything too intense today. We're just going to kind of mostly review. We'll do something that's a little bit different. We'll just like make it a tiny bit harder than things that you've already done, but nothing real intense. So just kind of talking about graphing and graphing lines, graphing inequalities, and combining them together. So for our warm-up, graph the lines. All right, well, we know we have our cherished slope-intercept form, y equals mx plus b, right, that we always use to graph, where m tells me the slope, b tells me the y-intercept. So we always first want to start by graphing the y-intercept, -3. And then the slope tells me where to move from that first point. So rise over run. This would tell me up 3, right 2. 1, 2, 3, right 2. And you can keep doing that as many times as you want. Up 3, right 2. Up 3, right 2. That way you have a better sketch of the line, right, rather than just connecting the 2 points and then, oops. Okay. And besides going up 3, right 2, then to go the other direction, you could also, to the other side of the line, we could go down 3, left 2. Down 3, left 2. All right, and you connect all these together. You know, I started strong and then it kind of faltered at the end there. But there's that line. 3x minus 9, not in slope-intercept form, so I'm going to make it in slope-intercept form. So I'm going to subtract 3x from both sides to move the 3x over, and then I'll multiply everything by -1 because I have negative y right now on the left side. I just want positive y. So y equals 3x minus 9. Okay. Start with the y-intercept, -9. Slope is 3, so up 3, right 1. Up 3, right 1. Okay. And we'll connect the line, or we'll try to. Again, it was okay until the end. All right. And we see that these two lines intersect at this point. So if we were trying to find, this is what, let's use a different color. This point is what we would call the solution. Right? Whenever we solve a system of equations, or like how we solved our nonlinear equations, we can also solve those by graphing and seeing just where do the lines intersect, because that'll also tell us the solution or solutions. Okay. All right. So let's use these principles, but for inequalities. So graphing inequalities, I don't remember where you learned that. Is it 1A, 1B? I really should know this considering I taught 1A in the fall. I don't remember. 1B, great. So a couple things that'll help us out. First off, we really prefer everything to be in slope-intercept form. Well, and for inequalities, it really needs to be, because we have to learn we have to shade. So we'll draw a solid line, remember, if we have less than or equal to or greater than or equal to. A dashed line if we just have less than or greater than. And we have to shade. So if the symbol is a greater than symbol or a greater than or equals to symbol, then we want to shade above the line. If it's a less than symbol of some kind, we want to shade below the line. All right, so let's see what this looked like in 1B. So I have a system of inequalities. I want to graph them. Now, first things first, neither of these are in slope-intercept form. So let's first, so I'm going to do the work for this first one down here. Just like with the last one, I want to move this 3x over to the right side. So I'm going to subtract 3x from both sides, but the 2y stays here, and the minus 2 stays here. All I did was move that 3x. And now I want to divide by 2, right? So divide everything by 2. So y is greater than or equal to negative 3 halves x. Negative 2 divided by 2 is negative 1. I would recommend probably, I like doing, maybe you saw this when I solve systems, I like doing this little starring just so I can keep track of what is the actual equation I'm using. And I'll go ahead and notice that since this is a greater than symbol, or a greater than or equal to, that I want to shade above this red line. Right now you might not be writing in color, so, but the point is I want to shade above this line. I'll go ahead and graph it. So minus 1. Rise over run, negative 3 over 2, so down 3, right 2. Down 3, right 2. Or up 3, left 2. Okay, either one works. And it is a solid line because this is greater than or equal to. Okay, so now let's do this equation. So I'll start off by moving the x over to the right side. So I'll subtract x from both sides. And then divide everything by 2. So y less than or equal to negative 1/2 x plus 1. Again, I'm just going to start to say that this is what I'm going to use to graph and to shade. And since this is a less than or equal to symbol, I'm going to shade below the blue line. But first, let's just graph it. And it'll be a solid line since this is less than or equal to. Negative 1/2 is the slope, so down 1, right 2. Down 1, right 2. Down 1, right 2. Down 1, right 2. Or up 1, left 2. Up 1, left 2. Up 1, left 2. All right, so that's pretty good. That's atrocious. Oh wait, I guess, I always forget I could just make a straight line this way. I'm so smart. And we have to determine what to shade. All right. We have 4 options. We can shade this region, this region, this region, or this region. So first, that's why I wrote these out here to help me. So I know I want to shade above the red line. Well, only this region and this region is above the red line. This region is below it, and this region is also below the red line. Okay, so those cannot be options. And then I also want to shade below the blue line. So out of these 2 options, the only one that's below the blue line is this one. So that one's gone. Oh wait, so this I actually want to shade So there we go. So that's something that you did back in 1B, right, of shading the inequality. So to keep just our practice with that good, let's do that some more, but let's crank it up just like one small notch. Okay, and that is we're going to add in a third equation. Okay, kind of similar to how you solve systems of equations in Algebra 1 with 2 equations. So now we cranked it up to 3 equations and 3 variables. Well, we're still keeping 2 variables for these, but let's crank it up to 3 equations. It'll make it a little bit more complicated for us and a little bit more fun as well. Everybody will be having fun, guaranteed. All right, or your money back. You guys sent me money, right? You were supposed to. All right, so let's put these in slope-intercept form. Let's do this one first. I'm going to move the x over to the right side, so I will subtract x on both sides. So negative 2y less than negative x minus 7. And then I'll divide by negative 2. So I'll divide everything by negative 2. So y. Negative 1 over negative 2, so that's positive 1/2 x. Negative 7 divided by negative 2, so that's positive 7/2. And now the tricky thing to remember is that since we divided by a negative, we have to switch the direction of the inequality. The inequality changes from a less than sign to a greater than sign. Right, so always remember that. If you multiply or divide by a negative number, then you flip the direction of the inequality sign. All right, so this is a greater than sign, so we will shade above this one. We could graph it now. We could graph them all together later. Let's just go ahead and do it now. So the y-intercept is 3.5, 7/2. Slope of 1/2, so up 1 over 2, up 1 over 2, up 1 over 2, or down 1 left 2, down 1 left 2. Okay, etc. You can go on as long as you want. Maybe I should shift this down so you guys can see a little better. Okay, this is just a greater than sign, so this we will draw this as a dashed line. Just a greater than sign, so we draw a dashed line. All right, 2x minus y. So let's first move the 2x over to the right. So negative y less than or equal to negative 2x plus 4. I don't want this negative here, so I'll multiply everything by a negative. So it becomes y. But when I multiply by a negative, I'm going to switch this direction. So greater than or equal to positive 2x minus 4. So the y-intercept. Here, I'll put my little stars. I'll also shade above this one whenever I get to the shading, but do the shading last. Up 2 over 1, up 2 over 1, up 2 over 1. Or down 2 left 1, down 2 left 1. It's greater than or equal to, so this will be a solid line. Maybe the trick is I need to move my arm in between. That works a little better. Maybe I was trying to do it just all in one pen stroke. Ugh. All right, and last equation, x plus y is less than 2. So subtract x from both sides. Y less than negative x plus 2. I don't need to divide anything because it's just y on the left side. It's not a negative. There's no coefficient. So, great. It's a less than, so we want to shade below. Y-intercept is positive 2. -1 is the slope, so down 1, right 1, down 1, right 1, down 1, right 1. Pretty boring slope. Oh no. Oh, wait. I messed up. I was too busy worried about drawing a straight line that I forgot. This is just a less than sign, so it should be a dashed line, not a solid line. That will help mask how terrible my line is, because it shouldn't be connected anyways. Very smart. Okay, and again, so now looking at this graph, I have a lot more options than before as to what region should I end up shading. On the last problem, we had 4. Here we have 1, 2, 3, 4, 5, 6, 7 different options. All right, and I think this is the best way to do this, is to think about all these options and then go through process of elimination. Okay, so it doesn't matter which equation we start with, but we should be shading above the orange line. Okay, so these are the 3 regions that are above the orange line. So that can't be it, that can't be it, that can't be it, that can't be it, because those are all below the orange line. Right? We also want to shade above this bluish, light blue, turquoise, teal. Maybe not teal. We want to shade above this line. So these are the only 2 regions that are above it. This region is technically below the blue line. If you imagine the blue line continuing up, then that region would be below it. All right, so we don't want that one. So there's only 2 spots left. And the last thing we want is to shade below the green line. So can't be this one. Therefore, here is the region that we want to shade. So it's just process of elimination. Okay. So put into slope-intercept form, graph the lines, think about the shading, and actually shade it. All right, last one. Just some more quick practice. So this first one, let's subtract 3x. So minus 4y less than negative 3x plus 8. Divide by negative 4 on both sides. So y, that would switch the direction because we divided by a negative. Negative 3 divided by negative 4, so that's positive 3/4. Positive 8 divided by negative 4, so that's minus 2. So here's one of my equations. I want to shade above. So 1, 2. Up 3, right 4. Up 3, right 4. Or down 3, left 4. Okay, since this is just greater than, not greater than or equal to, so it's just greater than, so we'll draw a dashed line. Second line, y less than 5. Well, I don't need to do anything to this, right? There's nothing on that left side besides just y, so this is already just one of my equations. All right, so the question becomes, do you remember how to graph the line y less than 5 or y equals 5? This is in the form of a horizontal line. Right, remember, a horizontal line is just y equals a number. Vertical line is x equals a number. So let's go up to 5. It's strictly less than, so there should be a dashed line. It's less than, so eventually we will shade below. And then lastly, for this third equation, again, this is actually almost done. If I look here, negative 2x plus 7 less than or equal to y. Well, the y is by itself. It's just that it's on the right side instead. But it's the same thing. In the same thing that if I write y equals mx plus b, or if I write mx plus b equals y, it's the same thing. It doesn't matter. So let me just kind of flip this around so that instead of negative 2x plus 7 less than or equal to y, it's y greater than or equal to negative 2x plus 7. All right, so we just kind of turned the whole equation around. But didn't have to do much math, so that's nice. Greater than or equal to, so we want to shade above. Y-intercept 7. Slope is negative 2. Down to right 1. Down to right 1. Down to right 1. All right. It's greater than or equal to, so it's a solid line. Pretty good. And now I'm going to think about all my options. 3, 4, 5, 6, 7, 8. 8 different options. Shift down a little. All right, that one off to the side is kind of hard to see, but it is still an option. If this pink line or not blue line, the pink line, we're still going, then this little corner is still a region. Oh, wait a minute. But you see these two here? These are in the same region. I accidentally split them up because of the x-axis, but that's not the case. These are all part of this. This is all one region. Okay. All right, so we need to shade below the green line, so that'll get rid of this option, and this option. We want to shade above the pink line, so that gets rid of this, it gets rid of this. And lastly, we want to shade above the blue line. So this is the only spot that's above the blue line, or the only region that's left that's above. This one is not. So it must be that that central area is the correct shaded portion. Oh, I'm so tired. Okay. And that's it. Right? Yeah. Okay, so again, just practicing stuff you've done before. We made it a little bit more hard, right? A little bit more difficult just by adding in another equation. So there's more regions to choose from for where should we shade. But if you just kind of go through it step at a time and think about it, it doesn't end up being too bad. These questions look like this on the PFA too, where it actually gives you the equations and it gives you the graph, and then there are like numbers throughout it. Like the region will be numbered off like 1, 2, 3, 4, 5, 6, 7. And what the multiple choice question is which region should be shaded. And so you just have to pick 1, 2, 3, 4, 5, 6, or 7. Which one is it? There also always is an option of this graph is not correct, which is really funny, I think. At least I thought so when I made it. So since the problem gives you the equations and it gives you the graph, I do want you to have to go through and check, wait, do these equations actually match this graph? Right? Because some of them have errors where the graph and the equations do not match. Right? And it might even just be a small error, but still it's an error. So if that's the case, then you would just pick the this graph is not correct or this graph is incorrect option. You don't need to worry about the shading at all. Right? But if you look and you say, okay, yeah, this graph is correct, it is made from these specific equations that it's showing me here. So then just go through the shading process of determining which area it should be. And that's all that I have math-wise.